Ladies and gents, welcome back. It's your favourite Elliot at Enginears. Offline, I've just been speaking to Andre about the biggest and best smile in the world that he has, that you'll see in the next couple of moments. So everyone welcome Andre at CausaLens. He's going to be talking to us something that is super prevalent at the moment, and CausaLens as a business claim to understand or reason better for what's happening in global economies. Okay, and we're going to break that down and dissect it and help them understand, or they can help us understand, in fact, how they best help their customers do what they do. Andre, do you want to give us an intro into your role at CausaLens, and let's break down CausaLens as a business over the next 20, 30 minutes and understand a little bit more about you guys and girls, what you do, how you do things.
Perfect. Well, first, thank you very much for the introduction, for the very warm introduction. And yes, about me, well, let me just tell you who I am, how I ended up at CausaLens. I'm the stereotypical quant. I did my PhD in physics. I was studying black holes. Then I ended up working at Goldman Sachs for 5 years. Goldman Sachs, I was responsible for validating models. So basically trying to understand what is the risk of the usage of quantitative models within the firm and within the financial sector in general. That was a very interesting role because you get access to essentially everything that the firm uses, and you get to understand from a more technical level why some of the crazy things that happened in the past, ever since computers arrived in finance, you get to understand why they happened from a technical point of view. And this role was essentially created and enforced by regulators after 2008. Because there was a serious lack of oversight into how firms dealt with financial models. After this stint at Goldman, I realized that actually I wanted to do a little bit more in terms of really understanding what is the best way to apply machine learning in finance and how to overcome some of the issues that exist within machine learning, and I hope we can definitely go deeper into that. So I joined CausaLens a little bit over 6 months ago, which right now feels like an eternity. And my role at CausaLens, I'm the director of applied data science, and I'm primarily responsible for ensuring that customers, they get as much value as possible from the usage of our product. So we are at CausaLens. We're roughly 50 people right now. We've been doubling every year since the inception of the company, and we're hoping to double again by the end of this year if everything goes well, if there is a positive outlook for the world again. We're aiming to get to 100. So we as the name suggests, we're very much focused on understanding causality. And why do you want to understand causality, right? I think that's a good question. So the company was founded with the goal of optimizing the global economy, which if you think about it in broader terms, right, it means that you need to be able to predict and understand a lot of moving parts. So the founders of the company, they have a financial background. They were quantitative traders before. They did have a large understanding of what works and what doesn't in that area. And the company became known very early for being the first, essentially, AutoML provider in the time series space. AutoML for time series is very hard. And in general, machine learning for time series is a very difficult subject, especially when applied to financial data, because of we can go into more detail, but essentially there's very low signal to noise in this data, and you do have a large availability of data, which means that essentially there is a lot of overfitting going on, right? And how do you deal with the problem of overfitting? The only way to do that is to really understand what causes what in broader terms. So this is where the company is right now. Currently, it has, if not the largest, one of the largest research labs in the world, specifically designed to tackle causality, not only in time series, but more broadly, like more specifically applied to time series. That is a big challenge.
Can I understand quickly, what do you mean by low signal to noise? Treat me as if I'm dim.
Yeah, okay. Absolutely.
What does that actually mean?
That's a very good question, because what we need to understand is that whenever you have a causal relation, right? So if I push this glass over the table, it's gonna fall and break. There is no ambiguity there. There is no stochasticity there, right? Everything happens in a very deterministic fashion. That's not always the case, because if you measure, for instance, the price of a stock, and I'm sorry, it's just that I'm used to thinking in terms of finance, so it just comes naturally. Yeah.
Please do.
Or even the movement of pollen in the air, right? That was basically the first application of stochastic calculus, essentially like when Einstein was looking at the movement of pollen in some fluid, right? That's how Brownian motion was invented. There is a component which is completely random. Why is it that's random? Because it's impossible for us to be measuring every single interaction that's happening, right? So we do observe, from our point of view, some motion that looks like it's flowing very naturally, follows the trend, and then some, random noise on top of that.
Okay.
And that's typically what you observe in every system that is stochastic by nature, meaning that, because there is a lot of moving pieces, you don't observe them. You will see some random fluctuations. You cannot really get rid of them. They're part of what you see. But at the same time, there are also signals. And by signals, what I mean exactly is that there are things that happen for a reason.
Yeah.
And they're going to affect this trend that you observe. But the way that they affect may be very, very small compared with the overall stochastic nature of the process.
I understand. Mm-hmm. Okay. Your platform that you've built, Causal AI, that helps optimize what they're doing. Sorry, customers optimize what they're doing without obviously betraying any confidence. Are we able to understand just a little bit about how that actually works? You don't necessarily need to talk to us about all the models that make up that platform, but it'd be useful to understand, I guess, some of what you're looking at, some of what's been built, and it may be how that translates back to your customers. And then we can go on to, I guess, how you help customers.
Oh, yes, perfect. No, I think that this is I can definitely go into a lot of detail without revealing anything that's too confidential,
no
proprietary. Yes, I think that it's worth thinking about breaking down the problem into a bunch of different steps, into how to go from raw data up until the point where you get value, right? Value depends from person to person. Basically, the idea is the following, right? You do have an objective. Typically, the objective will be to either forecast something or to understand the dynamics of something. Okay. And if you're a company, you're interested in making shipments from point A to point B. Mm-hmm. Again, there's a lot of moving parts in there, right? You want to predict what is going to be your cost of shipping from point A to point B. If you're responsible for securing the air freight for that, you need to understand what's going to be the cost of that airplane, how many pallets you're going to be able to put into the airplane, what is going to be your total profit from that product. So at the end of the day, it's a lot of little things that you need to predict ahead of time. To do that, what we offer is, as a first step, right, you need to understand where the signals are.
Yeah.
If you really want to make shipments from Tokyo to Beijing, perhaps a very strong signal is whether or not you're close to Lunar New Year, right? People are traveling a lot more. People are, offering gifts and things like that. So, but other thing that could be a strong signal for you in terms of predicting a shipment cost is just oil prices. And these are very different types of data sets, right? And you can get very different types of data sets as well if you look into demographics, right? Or if you look into how many online sales Amazon is doing on that area. So you need to merge together all these different data sets and then search extensively through them in order to find what the signals are. That begs the question, which is you're going to find a lot of spurious correlations, right? And what are spurious correlations in this sense? For instance, the typical example that I give is you want to understand what is going to be the performance of your solar panels, right? If you have a solar panel here, you want to predict its performance, and I give you like a huge data set with ice cream sales, with how many people are walking in the parks, what is the box office of whatever movie. You're going to find a lot of correlations to that, right? But it doesn't mean that ice cream sales is actually a driver of solar panel performance. You only need one data set, which is sunlight. If you make a model using ice cream sales, it's going to be inherently a worse model, right? If you have sun and ice cream sales in there, it's going to be a worse model than just having sun in there. Because the model is going to get confused because it's going to see things that are very correlated. It's going to learn to some degree that ice cream sales is a good proxy. But if tomorrow, people stop having ice cream and just have froyo or whatever it is, that's a new trend.
Shouldn't change the performance of the solar panels. Well, I hope so anyway.
Exactly. That would be crazy. Yeah. And so you need to drop ice cream, right? So big data, lots of data is not inherently better for the model. That's a big fallacy. Actually, oftentimes less data is much better precisely because you need to avoid these traps that have to do with overfitting. And that brings us to the next step in our pipeline, which is understanding causality. So we look for signals. We look we have a huge database of over 2 million time series of macroeconomic data where we look for signals. And the clients, they have their own proprietary data sets as well, which we can enrich. And so after we're done with this step, we find the signals, we test their causal relation. Testing causality, that's basically a new science. It's quite literally a new science that has existed for the past very few years. I think that the first paper was published around 2017. Although the idea goes back a long time, right? There's been essentially 50 years since Granger was talking about the idea of Granger causality and so on. But this is kind of like very early stage. At the moment, we have a lot more sophisticated algorithms that are relevant for the world in which you do have many signals, many of which carry redundant information.
Yeah.
And there is a lot of confounders there. And I can go into more detail later into what these terms actually mean. But let me have that as a takeaway from this step, which is after you find signals, it's very important for you to test their causal relation to your target in order to get rid of all these sort of spurious correlations, to get rid of all the ice cream sales essentially in your data set. After we're done with this, we need to build models essentially. And the way to build models, you can go all the way from a linear regression up to like a deep neural network. And that depends on the problem at hand. We try to keep it simple as possible for the problem, because the idea is that if you have a strong set of features, if you carefully selected them, if you treated them nicely, the correct transformations, the biggest hurdle is in constructing signals appropriately, constructing features in a very careful way. Once you do that, it's a question of what is the incremental gain in adding more complexity. I think that once again, a lot of the new machine learning techniques, or the new fashion right now, is to throw everything in a neural network with a given architecture. We would like to take a step back and then think, okay, from the point of view of clients, that's not always the best. So let's figure out what is the correct level of complexity that we need to add in order to do that. So here we deal with basically all the stack of machine learning models that exist in the literature. In addition to that, we also developed our own proprietary methods that are inherently causal. And let me tell you what I mean by that is that once we find causal relations, what we extract from the data is what we call a causal graph. A causal graph is essentially a visual representation of all the causal relations that you observe in your data and so on. Essentially, what I'm telling you is that the sun is the causal driver of solar panel performance. At the same time, like clouds is also a causal driver, right? And if you have some extra elements in your data, right, the solar panel performance is going to be a causal driver of the amount of electricity that is generated, your price of electricity, and then you can do this iteratively.
Nice. You said something quite interesting there. Understanding, I guess, the correct complexity for a customer that you're working with. Can we dive into that a little bit more and just understand maybe how you can do that more, and then look at some of that correlation between how customers use you to optimize what they're doing? So taking us back to correct complexity, it's a little bit like looking at right tool for the right job, or the right architecture for the right team or right domain. Correct complexity and how that correlates to, I guess, optimizing what they're doing, or showing where they need to improve or whatever else.
That's perfect. Yeah, I think that's a very good way to put it, because let me put it away, that there is a risk-reward ratio in increasing complexity. A linear regression, if you use the right set of features, is a very riskless type of model, because you know exactly, you look at it and you can attribute weights in a very straightforward way to your inputs. You get to understand exactly the counterfactual structure very, very easily, right? If I change this, how that's going to change. So there's a very straightforward attribution of variance, put it away. That means that a lot of customers, they're going to be very happy with the linear model, even if that means that if I jump into an ensemble model, I get better performance. Why is that? Because there is really a cost in terms of explainability. There is a cost in terms of black boxness, the like opaqueness of the method. So in that sense, let me put it away. We have customers who tell me, look, I would love to use that advanced method, but at the end of the day, I'm liable for the model risk in what I'm doing. And I need to explain that to the board or to my investors in a way for which the narrative makes sense. So getting that extra bit of predictive power by considering non-linearities in the data, or by considering, the fact that there's some weird stuff going on here, it's maybe not worth the risk, right? So let's stick to the linear because it gets the job done. And I can easily explain what's going on, right? And that depends a lot as well on what's the ROI for you, right? Well, what kind of return of investment you want to get. Because if you're a very secretive hedge fund, you don't have to answer to no one. You have your own capital. And for you, I mean, let's go for it. Let me try that. As long as I understand that this is not really overfitting. I mean, it's my, it's their responsibility, right? Theirs and theirs alone. There is that, depending on the type of customers, depending on who they're liable for, and depending on what they want to achieve and how difficult that KPI, right, that key performance indicator is, then they might try a bunch of different things. And I think that it's always it's not really part of the science, but it's more part of the business, right? The really understanding what their business is, to sit down with him and have that conversation. Like, look, this is how far we can go. This is where I think that the biggest value is going to be. Now tell us what is the risk reward ratio for you? How far do you want to go with the model? And then carry on from there.
Interesting. Okay. If we go slightly off piste, and we haven't actually discussed this, but obviously over the last 12 months, there's been some interesting changes in some of the markets. Okay. I'm sure maybe customers have responded well, not so well to some of that. Have you learned a hell of a lot in the last 12 months as well about you as a business, how you research, looking at causality? Have you learned a hell of a lot? Not necessarily on the science level or on some of the technology, but I think just at a higher level from a business and customer perspective. Have you learned quite a lot?
Yes, absolutely. I think that the learning experience have been, let me put it away. We learn better how to do forecasting, while at the same time, we understand that right now, customers are not as interested in straight, point in time forecasting as they were before. I think that more and more people have more holistic concerns into why things are happening rather than what is going to happen tomorrow.
Just about to say that, yeah. Okay.
And the second thing that they're interested is what if tomorrow this and that happens? So essentially creating realistic scenarios that stress their assumptions, that stress their current exposures, has been more and more important. And this is not only related to finance. And here I'm taking a more global approach to that, because finance hasn't been the only business affected. And to some degree, finance is very untouched by what happened in this past 12 months. Other businesses that traditionally weren't so interested in these sorts of questions, like retailers have taken a beating this year. Some of them are beating, some of them are swimming in cash. So like supply chain, right? Supply chain was completely disrupted. So not only because of the pandemic itself, but because of all of the...
there's ramifications across a number of different industries because of what's happened.
Exactly. Yeah. And so supply chain is completely changed. And what is going to happen if tomorrow there is a policy change that completely blocks this or that country out of the supply chain? What if this country enters the supply chain? What if the price of this commodity rises to, 200%? These are very pertinent questions right now for any company that is involved in this business, that essentially have a lot of moving parts and exposure to the global economy as a whole. So this has been more or less a shift. And I think that from our point of view, we invested a lot into causal inference technology, which is a step beyond what I was describing before, which is we understand what a causal structure is, or at least we have an idea that we want to test this hypothesis. So let's build models that eat this causal structure and then eat you essentially a machine that will allow you to ask counterfactual questions. Because we know that there are a lot of moving parts, right? So we know that this node right here, which is, GDP in this country is affecting some manufacturing metric, which is affecting this. And now how does this percolate in a way that's consistent, right? In a way that I'm not just percolating spurious correlations across this graph. So this has been one of the main successes in the past year, which is for us to understand how to consistently create these causal inference mechanisms, which allow customers to ask these what if questions, and then essentially, instead of forecasting the future, try to create scenarios that actually make sense, that are explainable in nature, and then measure their KPIs against the outcome of these scenarios.
It's quite interesting to hear the diversification of the platform, actually. Learning about you about a year ago, I think I saw a tagline somewhere predicting global economy. I thought, wow, hang on, this sounds like someone like Warren Buffett. Hang on a tick. But actually tweaking some of the complexity, if we talk about supply chain and we talk about finance, they have their own different challenges because of what's happened. So I think it's really interesting that you can offer customers that risk versus reward ratio on their different, if you like, challenges, and show them this is what you can do. And this is, I guess, some of the challenges that you potentially could bump into, but this is the reward on the other side of it. Not just saying this is black and white, this is what you'll achieve, or this is what you won't achieve.
Exactly.
So I am interested in the diversification. That's cool. I like that.
Yeah. Yes, indeed. I think it's important for businesses as well to realize that look, you're not an island, right? You're exposed to all these other things, and the sooner you want to send your exposures, you don't need to predict what's going to happen tomorrow. You just need to be very well prepared for scenarios that are very realistic. And the set of realistic scenarios has expanded quite exponentially in the past 12 months. So, yeah.
Can you share with us some of, not necessarily names, but I guess industries that you're helping at the moment, or have we covered them?
Yes, the industries are financials, right? All the way from the largest pension funds in the United States, very large banks as well, some, very proprietary, some prop funds, essentially. They're playing with their own money. They have their own technology. So we barely know what they are doing, to be fair. They are just using our technology in the background. Real estate as well has been a major one, especially considering what is going on in terms of the dispersion within commercial real estate. And who knows what's going to happen to offices tomorrow, right? So this is a very pertinent question at the moment for real estate. And then going away from investment more into the supply side, we do have retailers. We're helping retailers at the moment, like retailers like all the way from physical to technology retailers. And one of the new successes that we've had is also helping with healthcare. Essentially, one of the interesting aspects of healthcare is to understand if you're running clinical trials, right? You have two sets. You have the placebo set, you have the test set, and then within the test set, you compute statistical measures and then measure the effectiveness of your intervention, which is like a very scientifically rigorous way of doing things. But at the same time, it misses a lot of what's idiosyncratic to that person that made that person respond well to this treatment against that other person who completely failed, right? Because put it away, measure statistical averages, they may not represent the whole population in a straightforward way, right? You can have very bivariate type of distributions in your test set. For instance, if you have men and women may respond very differently to your intervention, but in average that affects to something that's unrealistic. So to understand better what causes this dispersion is one new area of work for us that has been very successful.
How do your technical challenges correlate with, I guess, customers' challenges? If there is correlation, or understanding at least some of your own technical challenges, I think that would be really cool to explore.
Yeah, I think that's an interesting question, because a lot of innovation happens because someone asked a question that hadn't been asked before. Someone came up with a data set that was just insane, and we need to really do a lot of work ourselves to understand that. So to be faced with challenging questions is always a good thing for us, because it helps us realize that we need to grow, and then we need to adapt our technology. I think that let me give you two examples, right? On the very low data, right? People talk about big data all the time, but small data that's a challenge in itself, because a lot of these industries, they are built on data that is sparsely available, that is often noisy and not collected with the best degree of accuracy. Take real estate, for instance, right? This has been one of the most successful areas for us in the past year, precisely because machine learning is completely useless in real estate, typically. Because of this overfitting, you have generally quarterly data, if not like annual data, and typically you have many data sets. It's very difficult to really go through a lot of data sets that are very sparse, and then to understand what really causes what. So this was one of the technical challenges that we embraced, and I said, look, we need to fix this. We need to develop technology to essentially make sensible forecasts and to allow us to understand the causal structure within the variables that are related to real estate. So it's this is like completely different from the typical machine learning problem, which is, okay, I have a lot of data, right? How do I ingest the data here? It's completely opposite, right? I have very low data. What can I make of this data? And then on the other hand, you do have the big data problems. And the big data problems, they typically come on the shape of, right, look, I have technology constraints in ingesting this big data. I have scientific constraints, because like if I measure low correlation, that doesn't necessarily mean that there is no causal relation, right? And sometimes high correlation doesn't mean anything. That there's no causal relation there. So typically, like these sorts of issues, they come to us with a very well-defined business background, right? With a very well-defined KPI. And then the challenge for us is to really translate this into a data problem, and then actually understand scientifically what we need to do in order to solve them. So yes, and I'll go back to the past 12 months, and I say that for us, technically the biggest thing in the past 12 months hasn't really been on the forecasting side. I mean, to some degree, we need to understand better how to make forecasts that work on this small data, because we're living in a completely different regime right now. But it has been more on like how to translate forecasts into KPIs, and how to better optimize KPIs given the forecast, and how to understand the inherent risk for your KPIs, given all these scenarios that are possible to happen tomorrow.
Nice. Okay. Talk to us a little bit about what could happen for the business over the next 12 months. You talk about there's growth. Mm-hmm. There's obviously a massively interesting scale at the moment with what you're doing. Just the sheer amount of data that you're ingesting. I can imagine there's all sorts of fun challenges to get your teeth into, exactly like you've just explained. What do you expect? Yeah, even if you can't think ahead to the next 12 months, the rest of this year, what do you think the business will try and go on to do?
Absolutely. So here I will separate the business side from the science side, and maybe I can give you an answer. One different answer for both of them, because let me start with the business side, because I'm on the business side, right? Although at core I'm a scientist, the first priority always is providing value. And then on the business side, our mission is to expand right now and to help as many industries as we can, and to really understand how to cement this interplay between the business and the science, right? We have a new growing science that is very young to some degree, and it has been a very interesting process for us to understand how to get that science, get that paper that appeared yesterday, like was just published yesterday, turn it into something usable, understand how it can be used for that specific problem, and then maybe 2 weeks from now have a product that is ready for deployment that is going to help a client. So on the business side, that's a goal, which is to be nimble and be quick, expand, while at the same time keeping in mind that our differentiating factor is a science, and then we need to be very, very flexible in understanding how well does the new science that comes up can affect business outcomes. And then on the science side, right, I think that it has been more and more apparent for all practitioners that the current state of machine learning is essentially undergoing a revolution. I think that we're really on the edge of a revolution when it comes to machine learning. We like to think of machine learning in the sense that there is like a barrier, right? Pre and post causal modeling. And it's like if you think of science back in the 17th century, right? People were gazing at the stars, gazing at the movement of the planets. And then, you had these beautiful models like the epicycles that had a lot of moving parts, and they were beautiful at predicting the movement of the planets, but they were completely useless beyond that, because it is really a curve fitting exercise, right? Essentially, you're looking at the movement of the planets, you create this crazy model that has the Earth in the center. But it took like a lot of guts for a lot of people to go and claim, look, the Earth is not the center of the universe, get rid of that. And then only when Newton appeared with an actual dynamic scientific explanation for gravity, right? Newton, Kepler, all of these guys, is that you have a model that was both predictive, but also allowed you to start asking meaningful questions, right? You understand that the apple that falls from the tree, that's exactly the same dynamics that's driving the movement of all the planets. So even though the epicycles, they were like this beautiful curve fitting exercise, you needed that extra bit of input for you to really understand what is going on. And I think that statistical learning, machine learning, that is incredibly useful and has basically transformed our society in the past 20 years. But to make that jump, and maybe another thing that we haven't discussed as well, which would be very interesting to go into, which is fairness and safety, right? To make that jump in a way that's fair and controlled, we really need to dig deeper into producing techniques that are causal in nature, that have a fixed dynamic embedded in them.
Talk to me about fairness and safety.
Yes.
Fair. Talk to me about it.
Yeah, it's true. No, and that's a fairness. That's a major topic in machine learning. You can understand it the following way, right? It's very simple. So you go to a bank, you ask for a loan. It's gonna collect all sorts of metadata from you. Where you live, how much money you earn, who are your parents, like what's your favorite flavor of ice cream. So all these sort of things are being collected by the bank.
And that correlates to the solar panel as well.
Exactly. They know all of that. And it's exactly the solar panel problem, right? Which is does the flavor of ice cream you eat affect your likelihood to pay you back? And then after you tell me, okay, this is crazy. Why am I hearing about that? But there are things in there that are very, very dangerous, right? If you think about if you go to America, right, which, going back to the conversation we were having offline, you have all these social issues. Many of them are racially related because of the history of the country. And because of the history of the country, there's a lot of segregation that happens when it comes to zip codes, right? You have neighborhoods which are traditionally very, very racially segregated, unfortunately. And if you give your zip code to a bank and they use your zip code to estimate your likelihood to default on your loans, and therefore that might affect how much interest you're going to pay on your loans, that is a very tricky subject. And a lot of people have been writing essentially about the perils of machine learning, and applied to these issues. And this is not the only example. There are many, many other examples in which what we think are very naive machine learning, it's like a data scientist coding this beautiful XGBoost model in the background, may actually have extremely negative impacts socially and actually accentuate these types of social issues that we have right now. And that is without going into this whole mess of how, algorithms are basically changing the way we think. Like social media is putting together, people that are anti-vaxxers, and what kind of consequence that may have for the world as a whole because of that.
Question. So you talk about, I'm just trying to imagine the situation, so I could be slightly wrong here, but are there ways, or is this a practice that you actually counter the models that you've built? So you talk about it's a nice environment and engineers are building models that they think are, let's just use the word acceptable.
Mm-hmm.
Could you counter those models and say, well, actually, what if we use that banking example
Mm-hmm.
of using the zip code example, could you just flip it essentially and say, well, what if there is potential issues for someone to be able to get a bank loan or paying high interest rates? Or is it you just look at, I guess, not necessarily the correctness, but you're looking at, I guess, the solution or the KPI. You've built something and it's your job just to step away from it. I'm just thinking about your fairness example. Are there practices that are designed to flip what we're building
Mm-hmm.
to ensure that we're trying to be inclusive or fair?
Mm-hmm.
Or is that something that's constantly evolving right now? Or am I just off-piste and I probably need to...
No. I think that's a good question, right? Because we do identify a problem. That the problem exists, and the problem is in production. So how to do that? So typically, the way that people try to counter this problem is they measure a posteriori what the model is doing, and typically the model is a black box, right? Which means that you have input, box, output. So this is everything that you see. So you measure input, you measure the sensitivity of your output with respect to the input. And then you come up with an explanation for what the model is doing based on that. So this is an a posteriori type of explanation, right? In the case of the epicycle, it's like you're moving your engine, right? And then you see the planets moving in there. You only know what the planet is going to do after you move your engine, right? You cannot say a priori that this is going to happen because there's a lot of moving parts. You can only see the output. Okay, now what we want to do and what we have done already is the following: is to say, look, this is nonsense. You need to have an a priori type of explainability. You need to be able to prove, as you prove a theorem, that if you change a protected class in your model, if you change someone's gender, if you change someone's race, the output is going to remain the same, right? It should be an invariance, or completely invariant of the model, right? You shouldn't even have to think a posteriori about the fact that this is going to be realized, because you can prove it as a theorem that this is a constraint that you can put in a model. And this has been another use case that was massive for us, which is the understanding that you can use this causal structure for you to say, look, A cannot possibly be a causal driver of B, and the model will respect that, right? It's really as if it's a theorem. And so the way to go forward is really for you to understand, okay, here are all the moving parts. Here are the moving parts that are protected, and your model needs to respect this protection.
Nice. Okay. I like that. That's a good explanation. I can digest that. I'm not super science, so I've got to hold my hands up and ask him questions at times, or try and explain it anyway. But before we wrap up, is there anything that you want to share with us that you think is particularly even more compelling about the business? Learning more about you and following and understanding the business since the summer of last year. I've been dying to get you guys on. We're obviously here. We're obviously going to create something that people can learn more about you. We've learned a little bit about science. We've learned a little bit about causality. And I think it's just been a fascinating listen to understand how you're helping some of your customers across different industries. And I think even going back to your clinical trial example, more examples than I think meet the eye sometimes. So I think that's been really nice to see. There's, for everyone listening, there's going to be lots of content below. There's going to be Andre's LinkedIn page, so you can check him out. And please reach out to the guys and girls. Please reach out to the guys and girls. And Andre, do you want to tell us a little bit actually about maybe that compelling point, if there is anything else that you want to share, but also across science and tech, what are you going to be hiring for? If people are listening, what are you going to be hiring for that you need to strengthen in the business around?
Well, thank you for that. It's been a great experience being here, and yeah, these are very pertinent topics. I mean, not only from the business point of view, but also the science is interesting. The engineering behind it is very, very interesting. Like a lot of thought went through actually understanding what is the best way to create a backend that can support not only the big data, but all the machine learning parts and all the causal infrastructure that we need. And to end on a positive note, right? Because we talked a lot about the perils of machine learning, how we're trying to fix that. But I think that the best way that I can end this in a compelling way is the following, right? So ultimately, the goal is to build a better world. And sometimes people get distracted by, the problem at hand. But at the end of the day, if you have a world that's fair, if you have a world that's more efficient, right? We're not wasting resources on things that ultimately do not serve anyone. And I mean, we had a lot of success as well with governments, right? Trying to allocate resources to reduce conflict. That's a very AI for good type of thing that actually has real world impacts and is also, it has massive implications in terms of resource allocation, right? You need to understand what works and what doesn't. And I think this type of scientific revolution is what we need in machine learning. And I think that people need to start thinking about how to really combine the power of statistical learning, power of machine learning, power of what we call artificial intelligence in general, with a more nuanced view of what is the underlying dynamic in my system, right? And try to focus more on understanding the underlying dynamic instead of just going through that curve fitting exercise over and over again. And that's where the real revolution is going to come from, is to really understand underlying dynamics of the data. So we're actively hiring in all fronts. We're looking for engineers to help us build the infrastructure. In my group, we're looking for talented people who not only have a passion for data science, but also want to understand the business problems, want to understand the economy and how to help the clients. And also on the pure research side, right, we are actively looking for people who have some experience in time series, who want to help develop the science even further and to actually think about it in more practical terms, right? How can this science be used in general?
I love that. Ladies and gents, I think you heard it, the scientific revolution for a better world.
Exactly.
As succinct as that. Everyone, links below. Reach out to Andre. Give it a like, share, mention with your friends, family, anyone that you think could be interested in, like Andre said, building for a better world. And I just want to say a big thanks. You've been awesome, super clear, concise, and thanks for coming to take the time to talk to us.
Thank you very much, Elliot. It was a pleasure, and thank you very much for having me on.
Pleasure. Peace and love, everyone. Enjoy. Hey guys, thanks for watching this episode. Massively appreciate you listening and checking in with us. If you want to find out more about us and what we're doing, please check us out on social media. What we're trying to do at Enginears is build a community to drive knowledge sharing and experiences. On Twitter, we can be found Enginears.io. It's no_. We've also got a website, which is enginears.io. These links will all be posted in the description. Any feedback and comments are massively appreciated. We're always looking to improve on where we can. Thanks, guys.